Hey everyone, welcome back. Today I'm going to be discussing VectorBT, Hyperfast Quantitative Analysis. It describes itself on its website as the ultimate Python library for technical analysis and backtesting at speed and scale. Sounds great, sounds amazing. Who wouldn't want that? In fact, several of you have already commented on the YouTube channel saying, please do a video on VectorBT and maybe compare it to some other backtesting frameworks that I've discussed on this channel, including Backtrader and PyAlgoTrade. So I thought on this video, I will do exactly that. I'm going to start off with a quick overview of all of the source code and make a couple more videos showing more in-depth how to use this particular library. We're going to go over how to generate a backtest like the one shown here, where you can, similar to Backtrader, program in a strategy that shows all your buy and sell signals. So this green arrow here is where you would buy, and this red arrow is where you would have sold, according to the strategy I've programmed. And it also shows your returns on each one of these trades and compares your performance against whatever benchmark you're trying to compare against. For instance, buying and holding the S&P 500 or buying and holding Bitcoin, seeing if your strategy would have done better or whether you're better off just sitting there doing nothing at all. So this is pretty cool. Lets you generate these nice web-based visualizations. It also lets you do this hyperparameter optimization. Some people might say this is overfitting, where you can run many different combinations of your strategy parameters. So for instance, if you're doing this moving average crossover, why not just try all of them, see which one is the best? You can generate this heat map to show which areas or which different combinations would have performed the best on historical data, in case that's of interest to you. You can also do things like label generation for ML models. So for instance, this one called XLB is labeling a local extrema. So you can see this is like a local peak and a bottom, and there's another peak, there's another bottom, and there's another peak in yellow. So maybe you want to run all of these labels on many different charts and feed it into some other system that you have. And also there's a bunch of other labels that you can generate. I ran this one on Zillow stock to show these uptrends and downtrends, and you can customize all these with different parameters, saying, you know, maybe highlight all of the 30% drawdowns, for instance. I'll also show you how to use this VectorBT data updater. So you see I have a class extending VBT data updater. And what this does is allows you to programmatically fetch new data on a schedule. So let's say you want to fetch data hourly or minutely or maybe every 15 seconds. You can fetch new data and program your strategy into this data updater. Maybe you want to place a trade or send yourself some type of alert when a certain condition happens on price or volume. And one other nice thing that's built in is Telegram messaging. So maybe when you receive this signal on new data that comes in, you want to send yourself a little Telegram message. I'll show you how to use that. And since everyone likes to create little bots, I'll program a bot in an upcoming video and we'll deploy it to Linode. So if anyone has any requests on a particular strategy to program in, I'm taking requests now and I'll make it on this channel and show it to you. I'll probably upload that like Thursday or Friday. So let me know by Tuesday or Wednesday what you want to see, and I'll program that in. So let's go ahead and get started by jumping into the documentation. All right, so I'm on the VectorBT website at vectorbt.dev. There's a link to the documentation, or we can go to the GitHub page and browse the source code. I'm going to click on documentation, and we're going to look at how to install this thing. So this is the package. It describes some of the benefits of using it. So we can just install it with pip as usual. So I have an empty Visual Studio Code editor here, and I have a script I just made called backtest.py. I'm going to run it just to get a command line. And I don't have it doing anything yet, so I can just do pip install as usual. So I'm going to do pip3 install VectorBT, and that will install the VectorBT package and let us use it. Okay, so now that that's done, we're all set up. So the first thing I want to do is briefly touch on VectorBT versus Backtrader. Everyone's always asking me, what's the best backtesting framework? First of all, I don't think it's PyAlgoTrade. I briefly tried that, but I just don't think that's the answer. There's not a ton of examples. There's not a ton of documentation there, and it wasn't clear to me how to do everything we want to do. At least Backtrader, there's a lot of documentation, there's a lot of examples, and a lot of tutorials on how to use it. VectorBT here describes a few benefits that I think are worthwhile. The first thing in the VectorBT documentation it discusses is performance. So if you look at the first paragraph, it says it was implemented in order to address common performance shortcomings of backtesting libraries. So if you've seen any of these videos where people make their own backtesting framework, you'll notice they just loop through a lot of data in order using Python lists, for instance, and a lot of them are really slow if you actually try to run it for large amounts of data or very short time frame data, like minute data, like a lot of you want to do. So maybe you want to run some strategy for every minute of data for the past 20 years, and you run one of these and you run it on every single instrument, it'll be really slow. In fact, if you look at my Backtrader tutorial, I believe it was, the stock trading app tutorial part 19, where I backtested opening range breakout with Backtrader, what I did was run this ORB backtest on every stock in the NASDAQ 100, so 100 stocks, and I did it for 3 different values of the opening range, and I posted the source code. You'll see where I did this opt strategy, so I optimized the strategy for the number of opening bars at 15 minutes, 30 minutes, and 60 minutes, and I ran through all of them, and I think this actually took hours. I can't remember the exact amount of time it took, but I had to let it run for a long time. It's not like I could just show it in real time on the video. So VectorBT claims to solve some of these performance bottlenecks by using these optimized NumPy arrays with this thing called Numba. If you go to numba.pydata.org, Numba makes Python code fast. It's an open source just-in-time compiler that translates a subset of Python and NumPy code into fast machine code. So there's all these optimizations that are happening under the hood here. And so it claims that it uses these highly optimized NumPy arrays, and it also overhauls the traditional object-oriented approach. And so if you look at the source code for my opening range breakout strategy, what you do in Backtrader is you extend this Backtrader strategy class. So I have this class called opening range breakout. And so there's this object here where I define a number of parameters, and you see how there's this next function. And what you do with Backtrader is you're basically playing the tape in order in this list, and you're saying next bar, next bar, next bar, if this, do that, if this, do this other thing, notify order, place an order, check on the order status. And so basically you're filling in this long next function over and over again. So VectorBT says it's able to process these arrays and run all these operations all at once somehow, so that it runs in a more highly efficient manner. So I haven't personally benchmarked a similar strategy on both of these to see whether this is the case, but looks like they have some benchmarks here showing using VectorBT versus just a regular pandas data frame, for instance, and it looks like it is much, much faster here, and it's definitely much faster than Backtrader, which I think just uses pure like Python classes and Python data structures. So this uses these very highly optimized NumPy arrays. The second comparison I'd like to do between VectorBT and Backtrader is the community and documentation. So let's say you adopt one of these open source backtesting library and you're relying on it for your own trading, your own strategies, and you run into a problem. How likely is it you're going to be able to Google it and find an answer? How likely is it you're going to be able to look in the documentation and figure out how to do it? And if you reach out for help, is anyone going to help you? If you submit a pull request or a bug report in the GitHub repository, how likely is it anyone's going to reply to you? And I'll say VectorBT does very well in this department. I found this documentation very well organized. There's a lot of these Jupyter notebooks here where you can run through a variety of examples. There's actually a dashboard example here using Plotly, and there's a few articles that the author of the library has written himself. And before I forget, let's thank the author, Oleg Polikow here, who has generously written many, many thousands of lines of code to implement this library that we will rely on. So thanks for that. If you click on Getting Help here, it looks like there's a private chat. You can go to Stack Overflow or the GitHub discussions here. And what I've noticed here that's pretty nice is this library is very actively maintained. So one thing I like to look at, how many stars, forks, people are watching it, so how active is it, and how many commits are there recently, because there's a lot of just dead projects out there, including some of the repositories that I've put online. So it's very difficult to maintain an open source project when lots of people are asking for things all the time, and you'll see the author committed code just 3 days ago. You see there's commits in August here. So this library is very actively maintained. If you look at the pull request here, There's a lot of closed pull requests and not that many of them open, meaning contributions are accepted and merged into the source code pretty frequently. On the other hand, Backtrader, while it has great documentation, and I will say the Backtrader documentation is quite good. There's documentation on each feature of the Backtrader library, and another nice thing about it is the community. So there's a forum here with tons of posts where people have asked each other questions and gotten answers, and here's the source code here. And so one downside I've noticed on Backtrader recently, when I first started discussing it, it was very actively maintained. But if you look recently, the commit frequency is getting less and less. So you see back in July 2020, there's only been a couple commits in the last year. And I think that's because the author, who replied to many, many posts on the forums, by the way, and did a great job, I find him a little condescending at times if you look at his posts when people ask questions. However, I could see where it gets irritating to answer the same questions over and over again, so he kept pointing people to the documentation. Good support here, but also this project is kind of considered complete. I think some members of the community have forked it and maintained like Backtrader 2 or something, but it's not quite as actively maintained by the original author, which means over time there's not going to be as many new features added, whereas VectorBT, I think, is a little more actively maintained right now, and there's a lot more commits and activity occurring right now, so I have a lot of confidence that this is being actively maintained. I also mentioned PyAlgotrade in the past. I want to say the documentation here covers some basics, like doing the very basic things, but if you actually dive in, it appears to be very well documented, but if you dive in more and more beyond these simple examples here, I think there's actually not that much there, and you'll have some trouble figuring out how to do new things with PyAlgotrade, and there's not like a forum or much activity in GitHub on that right now. So as of right now, I'm not really considering using PyAlgotrade much in the future. The third thing I want to talk about is ease of use. How easy is it to get up and running, write a backtest, maybe do some live trading using that backtest? Well, the easiest way to figure out ease of use is to look at a couple code examples for the same simple strategy between each framework. And so if you look at an example here on Backtest Rookies, this website shows a simple RSI strategy using Backtrader, and we've written something like this before on the channel. With Backtrader, if you're familiar with object-oriented programming, it's pretty straightforward, but also it's a little bit confusing how it works at first. But if you look here, what they do is they create a strategy, and you need to extend the Backtrader strategy class. You run some indicator in the constructor. So this is the RSI indicator. And so this indicator is running, and you give it a period that you're running it on. And then you just need to override this next function. And so you just go through all of the data in order, and you're just saying if you're not in the position, if the RSI is less than 30 by 100 units, else if the RSI is greater than 70, then you're going to sell 100 units. So you're just buying the oversold condition and selling the overbought condition. Just a basic strategy. Not a very good strategy, by the way. But so the way Backtrader works, before you run this class, what you want to do is instantiate this Cerebro object, which is like the brain. Cerebro is like the brain of the program. You set a certain amount of starting cache. You need to add the strategy to this Cerebro object. You need to provide it a data feed. So they're using Quandl here as their data feed, and they're using Apple between the time frame of for the year 2016, and they're just adding that data feed to Cerebro. They're running the strategy on that data feed. They're setting an initial amount of cache, and then they're calling this run to run it, and they're just showing the final value after running the strategy. So not that many lines of code, and then you can also plot that strategy using a candlestick chart. So that's not too complicated. Now let's look at what the equivalent looks like in VectorBT, and I'll go ahead and just write this code real quick just to show you a quick example. So this is an example on the documentation of VectorBT, and so you see the first thing you do is import VectorBT as VBT, and then you just need to get some price data. So it looks like they use Yahoo Finance to get Bitcoin prices, and so I'll do that real quick. So we have a simple empty script here, and I'm just going to import VectorBT or VectorBT as VBT, and then I'm going to do Bitcoin price equals VBT dot yfdata.download. So we're using the Yahoo Finance data that's built into VectorBT. And so this wraps a number of data provider libraries, which is kind of cool. So if I jump into here, you'll see there's yfdata here. So you'll see some other places you can get data from. So let me quickly talk about that. So we have Yahoo Finance data, but you also see it imports Binance as well. So we have a Binance client, which is kind of cool if we want to use Binance as a data source. They have a synthetic data source here if we want to generate fake data to test our application. We also have this geometric Brownian motion. So that extends synthetic data. So we can generate all this random data if we want to test that out. And then also we can use Yahoo Finance data, so that's good for pulling in stock data, right? And it can also pull in crypto data, but not as detailed of crypto data as other providers. And then you look, there's also a Binance data class here, which is cool because it includes Python Binance, which we've used for our Binance trading bot. And you can also see they include CCXT data. So I've also done a video on CCXT, the cryptocurrency exchange trading library, which allows us to use multiple cryptocurrency exchange providers like Kraken and Coinbase and a lot of other different providers, FTX, and we can even get 1 minute time frame data from these data providers. So if you want to focus on crypto, this is probably a good way to go instead of using Yahoo Finance. I don't think Yahoo Finance provides really detailed crypto data, but maybe it does. Or it probably only provides it on the top tokens, so you can probably get more obscure tokens using something like CCXT or Binance. Okay, so we got our data provider here, and so I'm getting the Bitcoin price, and I'll just take off the start and end. I'm just going to get all of it and get the closing prices. And actually, I'll get all of the prices, not just the close, and let's see what that looks like. So I get the Bitcoin price, and I print it like that. And let's see what the data structure looks like. So just with that one line of code right there, we're able to download Yahoo Finance data, and it gives us this YF object. And so if we want to get the actual data and show it, I need to call .get here. So I'm going to print BTC price.get, and let's look at that data structure. Okay, and that should show us a pandas data frame. So if I do .get, you see we have our typical date, open, high, low, close, dividends, stock splits, shows us the number of rows and columns, and it gets us all the Bitcoin data that's available. So Yahoo Finance only has this back to 2014 when Bitcoin was only $465 a share, now at $62,000. So buy and hold just there is pretty dang good. Okay, and so when we want to run our strategy, we don't want to run it on this entire data frame. We might just want to run it on the open or the close price. So in this case, I can do .get and I can do .get close, and that'll give me the closing price. So if I print the closing price like that, you should just see one column here. So we have just the date and just the close. So I'm going to assign that to a variable. And so I'm going to do closing prices equals BTC price.get close. And then also, let's just print BTC price.get, and I'll put the source code up. So that's our closing prices right there. And then we need to run some type of strategy on those closing prices. So you can see here, they're running, your typical fast MA, slow MA, and running that for, looks like a 10-day moving average and a 20-day moving average, and they're naming them fast and slow. The strategy we just showed on this Backtest Rookies is an RSI strategy. So to reproduce the strategy that we just saw, let's use the RSI indicator that's built into VectorBT. So I'm going to do vbt.rsi.run, and I'm going to run the RSI indicator on closing prices, just like this. So I'll do closing prices. Now, one thing that's kind of cool is I can jump into the source code. If you have the Python extension installed in your Visual Studio Code, I'm going to jump into RSI here, and this is the RSI that's built in to VectorBT. So you see this indicator factory is instantiated and applies RSI to that series of data, and you can pass it a variety of parameters like the window, for instance. And so I'm going to jump into this indicator factory. So you can see when I jump into RSI, I go into this basic.py. So this is organized into data. So our data had Yahoo Finance data, it had Binance data, and CCXT data. So this package is kind of cool in that it bundles in a lot of best-of-breed libraries that we've discussed on this channel, right? I've discussed what Yahoo Finance, I've discussed CCXT and Python Binance packages on this channel, and we've already used them. It also bundles a variety of technical indicator libraries. So if you look in indicator under factories here, you'll see on from here, if I type from underscore, you'll see there's from TAlib. So you can actually run any indicator that's built into TAlib, right? And you can run anything that's built into Pandas TA. So there's this from Pandas TA, and I think there's also from TA. So there's this Python TA as well. And so what you're able to do is call any indicator that's built into any of these other indicator libraries, and it provides a wrapper and a nice abstract way of accessing all of these, right? And so what I'm doing is just calling the basic RSI indicator here, but you'll also see, there's B bands, for instance, for Bollinger Bands. You'd probably find stochastic here, any other moving average or whatever else you can think of. It's probably built in here, and if it's not built in right here, you can probably use the name of one of the functions that are built into Pandas TA, which has like hundreds of them, right? So what we'll do here is apply the RSI indicator to the closing prices, and then we just want to calculate our entries and our exits. So what we can do here is set entries equal to RSI.RSI below 30, and then our exits equals RSI.RSI above 70. So we'll enter if RSI goes below 30, that oversold threshold that a lot of people use, and exit when RSI is overbought at 70, right? So if I print my entries and I print my exits, you should see some true and false values coming through saying whether we should enter or not, whether we should exit or not. And you can see there's my entries. They're all false right now. And it says exit true in the last few days. So it's saying I should be selling my Bitcoin. And that's why this is not a great strategy, because you don't want to sell your Bitcoin, right? So I'm going to look at the Bitcoin price on TradingView here. So we'll do BTC USD under crypto. Yeah, so let's look at that. And why is it saying to exit? So if I look at relative strength index and I plot this on the graph, you'll see that Bitcoin is currently overbought, right? Because it was like 40,000 a couple weeks ago, right? And then let me look at the daily chart here. And I have too much crap on my chart right now. Hold on, let me close this stochastic here. Okay, yeah, you can see Bitcoin was at like 40,000 about a few weeks ago, right? And then you can see it quickly moved up, and you can see it's in overbought territory. So according to this simple RSI strategy, you should be selling right now. Bold strategy, let's see how that plays out for us. So one thing you'll notice here is there's multiple trues in a row. It's because Bitcoin is overbought here for multiple days in a row, multiple closes, right? So since these are all consecutively true, we really just wanted to exit this one time when it first crossed over into overbought territory. And so what we're going to do here is set crossover equals true. And then also when it first becomes oversold, we're going to enter, and when it first becomes overbought, we're going to exit, right? And so if I run that, that'll only do true on the very first time when it crosses over the threshold, okay? So now we have our list of entries and exits. All right, now that we have our entries and exits, we need to apply these entries and exits to our closing prices and actually run a strategy. And so to do that, I can create a new portfolio variable here, and I can use vbt.portfolio, and I can do from signals. So you can see whenever I type dot here, my auto completion shows me a variety of methods. So there's a from holding, so we can see our performance when we just hold. We can do from orders to enter in a number of discrete orders and see the results. And you can also do this from signals. So I'm going to see the portfolio from signals, the performance from signals, and then I'm just going to pass it my closing prices, and then my entries and my exits. And I also need to pass it some initial cash. So I'm gonna do init cash equals, and we'll just do $10,000 here, right? And then so I should be able to just run portfolio.plot.show to show the results of this overbought oversold strategy. Okay, so I'm going to run that, and it should fire up a web browser for me. And let's see how it goes. And it runs just like that. And just with, how many lines of code do we have? It's like 10 lines of code, really. I put a bunch of spaces in there and printed out a lot of stuff. So you'll see just how easy this is, actually. So if I were to condense this down a bit, I'm not saying compress all your code. I'm just showing you that this is like 10 lines of code, right? And we can space it out a little bit to generate this backtest of this overbought, oversold strategy. You don't have to know anything about object-oriented programming really, and initialize the constructor and all this stuff, or Cerebro object. Just 10 lines of function calls, and you're able to get this nice visualization of buying and selling and see the performance. So there you have it. This is our performance. Look at us with Bitcoin trying to time it and buy and sell it. And there's a buy and sell, buy and sell, buy and sell. Let's look at this one. So this is our oversold. We sold here. We missed this entire run up here. And then we waited until it was oversold right here. We bought, but then we sold really quickly. And you can see we bought again. And then we sold at a loss. So you can see all these losing trades where we lost 40%, 20%, 23%, 25% on Bitcoin, one of the best, maybe the best performing asset of the decade. And then you can see the cumulative returns here. This here isn't our strategy. This is the returns from buying and holding. So that's the benchmark. The actual return we got from our strategy is down here. It looks like we didn't make any money. Maybe we even lost money. So you can see this RSI thing that people talk about all over the internet, all over YouTube. Turns out it's a horrible strategy, and it's not going to make you any money at all. So it's almost like we should have done the exact opposite.
Yeah, I should do the opposite. I should.
If every instinct you have is wrong, then the opposite would have to be right.
Yes, I will do the opposite. I used to sit here and do nothing and regret it for the rest of the day. So now I will do the opposite, and I will do something.
So let's try this out. Let's go ahead. Since that's completely wrong, let's see what happens if we buy when the RSI is above 70. So let's make the RSI above 70 our entry, and RSI below 30 our exits, and let's just reverse it and do the Costanza strategy and see what happens. So I'm going to run that. So it turns out Bitcoin goes parabolic, right? And so you want to actually enter when Bitcoin is overbought, right? So you buy when it's overbought. You catch this entire move, right? Because it's never oversold, right? And then when it's oversold, then you exit, right? And then it proceeds up really quickly. It's overbought there. You enter again. Then it's oversold, right? So it turns out actually buying the overbought condition actually makes you more money in this particular case. So yeah, I think that's it for now. I think this video's run a bit long. I touched on VectorBT versus Backtrader, made a few comparisons on the ease of use, the speed, the usability, the community, and the documentation. So far, I'm liking this VectorBT library quite a bit. And so in the next video, I will dive into some more of the functionality in depth. I'll use this data updater. I'll talk about Telegram notifications, do a new strategy, fetch some data in real time, do some buys and sells, and also deploy this onto Linode. Let me know if there's something specific you want to see. Otherwise, see you in the next video. Thanks.